Okay, in the previous two lessons, we talked about rectangular prisms, which is a box, right? We've talked about, let's see here, right? We talked about volume of rectangular prisms. We did surface area of rectangular prisms. We did triangular prisms, which look like this, right? They have a triangle at each end. We did the area, surface area and volume of those. And then we also talked about pyramids, right? So this is not going to be a very good pyramid, but there we go, right? So we did the surface area of those and we did the volume of those. Now we're going to move on to cones and cylinders and look at their volumes, and then the next lesson we'll get into their surface areas, okay? Now again, you can go to the formula page to get the volumes of these, but they're actually pretty easy. Think about, again, volume for these is the idea is what's the area of the base? Well, what shape is the base? The base is a circle, right? So how do we find the area of a circle? If you remember from our formula sheet, right? The area of a circle is pi times the radius squared. So if you had a piece of paper that was, whatever the radius is, and then you stacked it up. Imagine you keep stacking them in a pile, right? And we start filling this thing up, like say we fill it to there or all the way to the top, right? What we want to do is times it by the height. How much have we stacked up to fill it up? So volume formulas are all basically designed the same way. We find the area of the base and we times it by the height. So the area of the base is just pi r squared because it's a circle. So the volume is pi r squared, the area of a circle, times the height. How many of them have you stacked up essentially? Now, the volume of a cone is literally this formula here divided by 3. It's the exact same formula, but divided by 3. So if we think about this here, imagine we put a cylinder around this cone, a can sort of, right? And yet a cone here. So if we made, this is not the best version of this, so it's a pretty bad circle. That's really bad. If we put this cone in a can, right, that has a circle on the bottom and circle on the top, it's the same thing, except it takes 3 of these cones to fill up that one can. It seems like it should be half. Everyone thinks it should be half, but if we actually did this in class with an experiment where I could show you, it would take 3 of these. And there's lots of YouTube videos showing that of, kids basically filling a can and taking 3 cones. So it takes 3 cones to fill up one can that has the same radius and the same height, okay? So that equals 3 of these. So all we got to do is the same formula. It's volume equals pi r squared. That's the area of the circle on the bottom, times it by the height, and all you got to do is divide it by 3. So that question comes up a lot where it's how many does this take, or, it's 1/3, this is 1/3 of that, right? And you could times it by 3 to get back to the volume of the cylinder. All right, so let's check out a few examples here. Alrighty, so here we go. We have a cylinder, volume, pi times the radius squared. Remember, that's the area of the circle times it by the height. So, volume. I just leave pi as the pi symbol, and I hit the pi button on my calculator. The radius is 7, and we need to square it, not times it by 2. This is 7 times 7, not 7 times 2. Times the height is 12. Now, don't forget, if they draw the arrows like they did here, only going halfway across, that's the radius, okay? If they drew it all the way across, then we'd have to cut that in 2 because they'd be giving us the diameter. So that's really the only thing you got to look out for. If they give you the diameter, divide it by 2. So let me get my calculator here. All right. So I got my calculator up. Now again, I'm going to hit the pi button, right? Pi times, now 7 squared. I'm just going to hit times 7 times 7, right? Because it's 2 7s equals that. And then times it by 12. Boom. And the volume's 1847.2. All right, let me write that down. Here we go. Volume is 1847.2 is, I believe what I said, approximately. So I put a little dot above the equal sign anytime I round it. And we're back to cubed, because this is how many cubes would it take. Now again, this is not a box where you can fit cubes in. So you got to imagine if we had cubes that were 1 centimeter by 1 centimeter by 1 centimeter, right? Here's my box, right? Everything's 1, 1, 1. If we melted them all down, liquefied them, and poured them into it, that's how much it would take to fill this thing up, okay? Now, if we wanted to fit a cone in here, right? If we wanted to know the volume of a cone that fits right inside here, all we'd have to do is just divide that by 3 to find the volume of the cone. All right, so now looking at our cone here, thing I got to remind you about again, one more time, the slant height versus the, let me zoom in here, versus the true height. When you are doing volume again, we want the true height. So we want this height right here, okay? We do not want the slant. So if they give us the slant, guess what? We're gonna have to use Pythagorean theorem, okay? So let's go back and check that one out. All right, so back to this question here. And they gave us the true height, so we are okay. So the volume of this one is pi r squared times the height, just divided by 3. It's the same formula. So pi times the radius is 3, square it, not times it by 2, times that by 10, and then divide it by 3. All right, so we can pull our calculator. You can even do a little reducing here if you want, but let's get our calculator. We'll just punch it all in quick. All right, so 3 squared is 9, right? So 9 times pi equals this. Times it by 10, we get this. And let's divide it by 3. Boom, there you go, 94.2 approximately. So 94.2 approximate centimeters cubed. All right, okay, let's check out a couple more quick questions here. Okay, so let's look at this cone problem. Now we're going to get into more of the real grade 9 problems because everything else has been pretty easy so far. Just punch in the numbers and away you go. The problem with this one is they gave us the slant. But to find the volume, when you look at your formula sheet, it says you need the height, which is this here, right? So we need the height. We don't have the height. Now, this is going to be the radius here. We know this is the radius because it's the line they drew is only halfway across. So essentially what we have is a right angle triangle here, right? So what we need to use is Pythagorean theorem. Sorry, that's really sloppy there. You get the point. All right, so c squared equals a squared plus b squared. So let me write that down. Pythagorean theorem. C squared equals a squared plus b squared. Which side is the c? The c is the side across from our 90-degree angle that I drew in. So it's 15. Now the other two sides can be a and b. It doesn't matter who's a and who's b. So I'll make the a the h, okay? And let me just label stuff. And I'll make the radius the b. All right, so 15 squared equals the height squared plus 9 squared. So we're going to square both of these numbers. 15 times 15 is 225. H, we're going to have to leave as h squared because that's what we're solving for. 9 times 9 is 81. We're going to go 225 minus the 81. And that's going to give us 144. And then we take the square root of that, right? So I'm just going to flip this around, square root of 144. Now, if you don't have a perfect square, what I would recommend is just leave it as is. But this one is a perfect square because when I take the square root of 144, I get exactly 12. So if I had gotten some ugly decimal number, I would just leave it like that for now. But we got a nice number, so there we go. So now I can find my volume, right? Volume is the area of the circle on the bottom, pi r squared times the height divided by 3. So pi times the radius is 9 squared times our height, which we just found is 12 divided by 3. So this is where you've got to watch out for it. You need the height, not the slant. All right, so don't forget when you square the 9, it's going to be 81, right? So you got to square that. It's 81. Times it by pi, times it by 12, divided by 3. And you get approximately 1,017.9 meters cubed for our final answer. All right, I just want to do one final example here, okay? Okay, in our last example, what's going on is we're going to be given the volume. So let's see. Sophia's constructed a cone-shaped funnel from paper. The funnel has a volume of 62 centimeters cubed. So they're giving us some of the information. They're also giving us the radius, and it has a radius of 4. But what is the height? That's the problem. We're not looking for the volume this time, we're looking for the height. So let's take kind of a summary of what we need when we use our formula, right? The formula is volume equals pi times the radius squared times the height divided by 3. Well, our volume we have is 62 centimeters. Our radius we have is 4 centimeters. We don't know the height. That's what we're looking for. So let's substitute everything we know into this formula, right? 62 equals pi times 4 squared times height divided by 3. Now what we need to do is basically use reverse operations to isolate the h. We've done this a lot this year, right? We need to get rid of everything on that side to solve for the height. Now, what can we do first? We have a couple options. You know what I'm going to do first is I'm going to square this 4 and just get that right out of the way. So 62 equals 4 squared is 16. I'm just going to put the 16 in front of the pi just because it looks nicer that way. So I just switched their spots, okay? I just basically switched those two. Now, we want to get the height isolated. Do you remember what we do when we're solving and we are dividing by something? What we can do is multiply both sides by that. So I'm going to multiply both sides by 3. When I multiply this side by 3, it cancels out. When I multiply the 62 by 3, I get 186. All right, so we've got that. Now, I want to get rid of the 16 and the pi that are multiplying the h. So what's the opposite thing to do? Why don't we divide by 16 and pi, right? Divide by 16 is 1. Divide by pi is 1. We just got to divide the other side by 16 and pi. So I'm just going to flip this around here. It turns out our height is 186, which was 3 times 62, divided by 16. divided by pi. So when you punch this in your calculator, be careful. Don't do this. Don't go 186 divided by 16 times pi. Because what it thinks is you want to divide it and then multiply. No, what you want to do is go 186 divided by 16 divided by pi. Okay, so punch it in that order. And if you do, we should get approximately 3.7 centimeters for the height. So now watch out for this type of question. There's going to be a bunch of these that pop up. I only did it so far with this, with a cone. But the idea is, what if you know some of the measurements and you want to solve for some of the other measurements? You're going to have to use your reverse or inverse operations to do that, okay? All right, so give this week's work a try and don't be afraid to ask questions. Thanks.